Well, welcome to this online revision session for AQA FP3, in which we were looking at the January 2010 question 5 on solving second order differential equations. So you can see in this particular question we have a second order differential equation, and in the first part of the question we're asked to find the particular integral, having been suggested as to what form it is in terms of px e to the minus 2x. And having found the particular integral, we then go on to find the solution to the problem under the given conditions. So quite a long question, but hopefully one we can work through quite clearly. So finding the particular integral. We know the particular integral has to be a solution to the second order differential equation that we've been given. So we know that y equals px e to the minus 2x. So we now need to find dy by dx. And we can see px e to the minus 2x is a product. So we differentiate the px, which gives us p, and multiply it by e to the minus 2x. And then we differentiate the e to the minus 2x, which gives us minus 2 e to the minus 2x, and multiply it by the px. So it's application of the product rule. Hopefully you got beyond having to apply the formula every time, and you can do that by inspection, if you like, by looking at it and realising it's in two parts. Similarly, we then have to find the second differential in order that we can then substitute both of these into the original equation. So again, differentiating the p e to the minus 2x is going to give us minus 2p e to the minus 2x. And then again, we then have a product for this second part. So differentiating the minus 2px gives us minus 2p e to the minus 2x, and then differentiating the e to the minus 2x, we get another minus 2 times the minus 2, so that becomes plus 4px e to the minus 2x. So we can see the first two terms are actually the same. So if we now substitute, we are going to get minus 4p e to the minus 2x plus 4p x e to the minus 2x. So that's substituting into the d2y by dx squared. Then we get 3 lots of the dy by dx, so that's 3p e to the minus 2x. And then it's minus 6 lots of px e to the minus 2x. Then we got 2 lots of y. Well, 2 lots of y is twice p x e to the minus 2x, and that has to equal 2 lots of e to the minus 2x. Now if we check the px e to the minus 2x, we've got 4 of them here, minus 6 of them there, and 2 of them there, so they all disappear. And so we're now only left with p e to the minus 2x's. So we're going to just equate the coefficients of e to the minus 2x. And that is going to tell us that minus 4p plus 3p equals 2. So that tells us that P is equal to -2. So our particular integral in this case is going to be y equals -2x e to the -2x. Okay, 4 marks here for doing this particular question. So obtaining dy by dx and give us a mark at this point. Similarly, obtaining an answer for the second differential will give us 1 mark. For then substituting into the differential equation will give you a mark, and then obtaining the correct value for P will give you the 4th mark. Okay, you'll still get a mark for that part if you've made just 1 error on the way through. Okay, second part then, we're going into finding the solution to this second order differential equation. So remember, having found the particular integral, we've got to find the complementary function, and in order to do that we solve this equation when it's equal to 0, and from that we find what we call the auxiliary equation, and the auxiliary equation is made up of the coefficients of the d2y by dx squared. Well, there's 1 of them. There's 3 lots of dy by dx, and there's 2 lots of y. So our auxiliary equation would be m squared, there's just 1 of them, plus 3m plus 2 equals 0. And we can see that factorises quite quickly into m plus 2 times m plus 1 equals 0, and so that gives us 2 values of m as -2 and -1, and so we can write down our complementary function as being a e to the minus x plus b e to the minus 2x. And that then gives us our general solution, because our general solution is made up from the complementary function plus the particular integral. So that will be equal to a e to the minus x plus b e to the minus 2x minus the 2x e to the minus 2x on the previous page. Okay, now from that general solution we now need to find the one solution that fits the conditions, because we're told that when x is 0, y is 2, and when x is 0, dy by dx is 0. So we start with the first one, which was when x is 0, y is 2. We can substitute that into our general solution, remembering that e to the 0 is 1. That gives us a plus b, again e to the minus 2x is also 1, and when x is 0, the third part here is just 0. So that gives us our first equation. We know that a plus b is equal to 2. Now, to substitute in for the second term, we've firstly got to find dy by dx from our general solution. So we've got to differentiate our general solution. So that gives us minus a e to the minus x minus 2b e to the minus 2x, and then we got a product here, so again we differentiate. The minus 2x gives us minus 2 e to the minus 2x, and then we differentiate the e to the minus 2x, so that's going to give us plus 4. I'm going to multiply it again by minus 2 there, x e to the minus 2x. So again, we know that when x is 0, dy by dx is 0. So we can substitute those two conditions in here, and we're going to get 0 equals, well again, e to the minus x when x is 0 is 1, so we get minus a minus 2b, and then we get a minus 2, and then this last term, because of the x being 0 here, is 0. So this is our second equation. So we've got to solve those pair of equations 1 and 2 simultaneously. So we can see we've got a positive and a negative x, so the simplest thing to do is just add these two together. We add 1 and 2, we're going to get 2 equals minus b minus 2, and so that tells us that b is equal to negative 4, and if we then substitute that into a plus b equals 2, that tells us that a is going to be 6. And so our solution that we're looking for is going to be, well, it was y equals a e to the minus x. Well, a is 6, so that becomes 6 e to the minus x. And then b is negative 4, so that gives us minus 4 e to the minus 2x. And then we end up finally with the last term, which is minus 2x e to the minus 2x. Well, there's 8 marks available in this part. So obtaining correct values here for m gives us 1 mark. For then writing down the correct complementary function will give us a mark. And then the general solution, being the sum of the two separate parts, stating that correctly will give you a mark. Obtaining the fact that a plus b equals 2 when you substitute x as 0 and y as 2 will give you a mark. Realising that you've then got to differentiate in order to be able to substitute the second conditions in, and getting the correct result there will give you a mark. Obtaining then this second equation that you've got to solve will give you a mark. Solving them correctly and obtaining the arbitrary constants, and then finally correctly stating the solution to the differential equation given the conditions that we had. Giving you a total of 8 marks for that final section. Well, hopefully you found that solution helpful. For further work to help you with your studies, please go to the Further Maths Support Programme website.